So in this video, we're going to use a calculator to approximate each expression in radians, rounded to 2 decimal places. So the first one is the secant inverse of 3. Okay, so secant inverse of 3. So let's make sure we've got our calculator in radian mode. So I'm going to click the mode button and we're in radians. Good. Okay, second quit to get out. All right. So what do? Trig inverse tells us the angle. So I set this equal to theta. And now I use my property. So I secant both sides. I get 3 equals the secant of theta. As long as theta is between 0 and pi, with theta not equal to pi over 2. That's my restriction. So I want to find cosine because cosine has the same range as the cosine inverse has the same range as the secant inverse. Okay, so what am I going to do? I'm going to do the reciprocal here. So this is equal to 1 over cosine theta. So I have 3 equals 1 over cosine theta. And so if I swap the 3 in the cosine position, I get cosine theta over 1 equals 1 over 3. Okay? So, and all I did was cross multiply there and solve for cosine. Okay? So here's what I need to do now. I need to draw a triangle, right? What do I know? Well, I know all students take calculus. Okay, everything's positive here and cosine is positive down here. Well, I'm only dealing in the first and second quadrant from 0 to pi. Okay. Now, if I have the cosine of theta is positive 1/3, that means that I can't be in the second quadrant, so I've got to be in quadrant 1. Quadrant 1 is where my dot is going to be. All right, so what does this tell me? Cosine theta is x over r. So my x value is 1. So I go over 1, and then I go out a distance 3. Okay, that's the r. So my question is, maybe I'm going to need to find this other side here, maybe not. Okay. So, what do we do here? Well, I think I can just get away with calculating the... So look, all I'm looking for is theta, right? So I think all I've got to do is run the cosine inverse function. So if I do the cosine inverse of both sides, I get the cosine inverse of 1/3, which is okay because this value right here is in our domain. So between -1 and +1, so I have theta equals the cosine inverse of 1/3. So if I type this in my calculator, cosine inverse 1 divided by 3, close parentheses, enter, 1.23 is my answer. Okay, 1.23. All right, the next problem we're going to do is the cosecant inverse of -4. Cosecant inverse of -4. First thing I do, set it equal to theta. So that tells me that -4 is equal to cosecant of theta. And this is true for -pi/2 to pi/2 for theta, as long as theta is not 0. Okay. We know that cosecant inverse and sine inverse have the same range, except where it's undefined. So I'm going to convert this to be 1 over sine theta equals -4 over 1. And with a little bit of algebra, I get sine theta is equal to negative 1/4. Okay, sine theta is negative 1/4. Now, for this problem, I have a sine inverse button. So really all I've got to do is apply the sine inverse to both sides. Negative 1/4 is in my domain for sine inverse. So theta is equal to sine inverse negative 1 divided by 4, close parentheses, negative 0.252, so negative 0.25. Roughly, right? So a little squiggly for approximate. Okay. The next problem, what are we doing here? We're calculating the cotangent inverse of 1/2. Now, cotangent inverse, this one is a little bit trickier. We don't have a cotangent inverse button on our calculator, so we're going to have to get a little creative. All right, if you'll remember from previous video, we talked about cotangent inverse had the same restrictions as the cosine inverse, so we're going to utilize our cosine function on this problem. So first thing I do is I set it equal to theta. Okay, and so this tells me that 1/2 equals the cotangent of theta as long as theta is between 0 and pi. Now, what do I know about cotangent? Well, cotangent is equal to 1/2, so that's obviously positive. Now, if all students take calculus, okay, if all students take calculus, everything's positive in the first quadrant, and tangent and cotangent are positive in the third quadrant. However, we're restricted to quad 1 and quad 2. So in quad 2, it's negative, so there's no way that you can have that. So what do we know? We know that our triangle, wherever our dot is going to be in Q1. Okay, so that helps us figure out where we are. The cotangent is a positive number, so that means we got to be in Q1. Okay, so I'm going to draw my triangle in Q1. So what is cotangent? So cotangent theta equals what? Tangent is y over x, and so cotangent is x over y. And this is 1 over 2. That's what we found right there, right? So that tells me what? I go over 1, okay, and I go up 2. And so what I don't know is the hypotenuse, that r, yet. All right, and so this is my angle theta. So I know that this angle theta, cotangent inverse, that is the triangle that you can draw from it. Okay, now all I'm looking for is theta, right? I'm looking for the cotangent inverse of 1/2. So I'm going to use trig here. Okay, I'm going to use trig here, and I'm going to get the cosine inverse going on. And why do I use the cosine inverse? Because the cosine inverse has the same range as the cotangent inverse function, except where it's undefined. So cosine inverse theta and cotangent inverse theta have the same range, except at the undefined points. All right, so whenever I draw my picture and I use Pythagorean theorem, 1 squared, a squared plus b squared equals c squared. That's 1 squared plus 2 squared equals r squared. So 1 plus 4 equals r squared. So 5 equals r squared. Now when I take the square root, I get that plus or minus, but this distance here, r, is positive, so that's square root of 5. Okay? That doesn't simplify any. So if I'm going to find this, right, using trig, I know the cosine of theta is equal to what? Cosine of theta is x over r, so that's 1 divided by square root 5. So 1 divided by square root of 5. Simplify, multiply top and bottom to rationalize the denominator, I get square root 5 over 5. Okay? So what do I have? I have the cosine of theta equals square root 5 over 5. Now to get theta by itself, I'm going to do cosine inverse both sides. Cosine inverse of cosine equals cosine inverse of square root 5 over 5. And so this tells me that theta equals, and I'm going to go to my calculator, do cosine inverse of square root 5, and then I'm going to go outside the square root. I'm going to divide by 5, close my parentheses, and I get 1.107. So rounded to 2 decimals, that's 1.11. So roughly 1.11. Okay? Last one right here. So with this one here, I'm doing the cotangent inverse of -2. So cotangent inverse of -2. So I'm going to let this equal theta. And so this tells me that I have -2 equals the cotangent of theta for theta between 0 and pi. All right. Now here, instead of cotangent being positive, cotangent theta is actually negative. It's equal to -2. So all students take calculus. It's positive here, it's negative here. So in from 0 to pi, which is our restriction on theta, we know we've got to be in this second quadrant here, okay? But since it's negative. So how do we handle this? When I draw my picture here, I'm just going to put a dot out here. It doesn't have to be perfect. I just need to make sure that I get my sides correct. Okay. What do I know? Cotangent theta is x over y, which is -2 over 1. That's how I write -2 as a fraction. Okay. Now, how do I know x is -2 and not y? Well, y in Q1 and Q2, y is positive. But in Q2 over here, x is negative. In Q1, x is positive, right? But since we're over here in Q2, I'm going over here a -2 distance, okay? And then I'm going up a +1 distance. So my y is +1 and my x is -2. So really, the only thing left that I need to figure out is what r is. So I do 1 squared plus -2 squared equals r squared. So I get 1 plus 4 equals r squared. So when I solve for r, I get square root 5. So square root 5 for my r. So we run through the same game again. Cosine and cotangent have the same range, except for the undefined values. So what does this help me out with? Well, if I do the cosine of that triangle, so this theta here, cosine is x over r. So that's adjacent, -2, divided by hypotenuse, square root 5. All right. So what do I have? I have the cosine of theta equals -2 over square root 5. Now, if you want to rationalize, great. If you want to leave it like that to plug in your calculator, that's okay too, since we're getting this decimal approximation. I'm going to do cosine inverse both sides. That gives me theta on the left. On the right, it's cosine inverse of negative 2 over square root 5. And so I'm going to go type that in my calculator. Cosine inverse negative 2 divided by a square root of 5. Okay. Enter, and that's 2.677, which rounds up to 2.68. Okay. So really the cotangent one, those are the ones that are kind of the trickier problems for those sections. The secant and the cosecant, the big trick, first things first, set it equal to theta, and then once you get that, do the inverse function of the inverse, which is just the regular function, and then convert to sine or cosine depending on what you're dealing with. And once you get into that form, solve for the sine or cosine, and then you can use those inverse functions that you have in your calculator to get your answer. Okay. The trick here with this other one, let's see. I mean, what would happen if we did the same kind of thing going on with the cotangent? So let's see here. I think the biggest thing that you run into is the fact that your ranges are changing. Like if you did a tangent inverse here, instead of it being from 0 to pi, that theta rotates, like it's going to be like negative pi over 2 to pi over 2. Like tangent theta is restricted from negative pi over 2 to pi over 2. So that's where, you've got a different domain for your trig function. So that's why, they're trying to be careful so that you don't get extraneous solutions there. So that's why, we use the cosine inverse here. And so I need to draw the triangle. That's that extra step that you didn't have in these first two problems, right? You got to draw the triangle and see how it relates with respect to the cosine adjacent over hypotenuse here. And when you follow through, then you can find the cosine and then run the same game that you did with your secant inverse. Okay, you're doing that reciprocal and then going from there. All right, guys, good luck.